Right, we're starting with our lesson 9M 5.1 and it's on circle geometry. So we're now busy with geometry and in specific circle geometry. So the first couple of pages just basically revision of what you already know, plus some terminology regarding circles that you have to memorize and know. We're going to take a look at it just now, and then we're going to focus a lot on the exercises as well as the homework. But you will see the examples, they're quite self-explanatory, but I'm going to explain it also to you while we're busy going through it. And then we will, in the end, just focus a lot on the exercises as well as the homework. Right, so in this lesson, we are going to study geometric facts and theorems specifically applicable to circles. So in previous lessons, we looked at geometry of lines, angles, triangles, and polygons, and the info and knowledge you gathered on these specific sections of geometry, you're going to apply to the lessons that's beyond this point, as well as for the exam. All the three reasons you have already learned are still applicable. All the reasons you have already learned are still applicable and are continuously used in problems relating to circle geometry. So you're going to intertwine the old with the new. So when we look at terminology regarding circles, I want you to make a summary of this sketch specifically, and you need to know each of the following. So M over here is the center of the circle. Line AB we call a chord. So it's called a chord, so you need to know the difference between the diameter and a chord, yes. And then CD is an intersecting line or transversal. I'm going to highlight it in purple for you. Right, so CD is a transversal or intersecting line that you already know. EF, we know, is the diameter of the circle. MH is the radius. As well as MF. So together, the plural radii, then PHQ is a tangent to the circle M. So PHQ is a tangent. A tangent intersects or touches the circle at one point. So for example, this specific point here. So please take note that a tangent intersects or touches the circle at one point only. Then KL over here is a section of the circumference and is named an arch. So there you have your arch. Segment. What is a segment? This is the area enclosed by a chord AB, and I'm going to color it in purple here. No, let's make it another color. I'm going to color it red. Right, so segment is the area enclosed by a chord, which was the blue one, AB of the circle, and an arch. C shaded area. There you have the shaded area in gray. And then the diameter or diameter is the longest chord in a circle. The green one there. So chord, just a normal average chord, that one is the diameter, which is the longest chord in a circle. Right, then we move on to important facts. centers and tangents. So I'm going to highlight it, and you're going to make a summary of it so that you know what we are referring to when we talking about tangents and concentric circles, etc. So when a sketch of a circle is drawn, the center and any tangents to the circle must be specified. So that's very important. We cannot guess in geometry or make assumptions. So they need to specifically mention specific data like tangents or the center of a circle, for example. One may not, and this is very important, one may not assume that the dot in the middle of a circle is the center. So this is something that you have to make a very big NB of. One may not assume that the dot in the middle of a circle is a center. They have to mention it. It must be specified as the center. So that's very, very important. The same rule applies for tangents, right? So I'm going to NB this for a reason, so that you will know that this is not just a small insignificant bit of information. This is something that many learners make silly mistakes with by forgetting that you cannot just assume that the dot in the middle of a circle is the middle of the circle. They have to specify it. Right, more information. When they refer to concentric circles, two circles with the same center, but their radii differ in size. So obviously, the smaller one in the middle will have a shorter radius than the outer circle. Then formulae, this is known already to you. So this is the circumference of a circle to pi radius and the area of a circle pi radius square. Then concyclic, new one for you. Points that are concyclic all lie on the circumference of the same circle. So I'm going to highlight them. A, B, C and D are concyclic. What does that mean? Points that are concyclic all lie on the circumference of the same circle. So it has to be the same circle. It cannot be two different circles. It has to be the same circle. Then theorems. Another heading for you. A theorem refers to a true statement of the nature. The words if, and then there will be additional information between the words if and then. So it will look like something in this format. Some well-known theorems. If, you see, if a line is a straight line, then. So it will start off with if, blah, 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 and then. So you have to identify these words. And when you write a theorem, then it needs to be there also. If a line is a straight line, then the adjacent angles on the straight line add up to 180 degrees. So angle A1 plus angle A2 plus angle A3 equals 180 degrees. Then, if two lines intersect, then, you see, once again, it starts with if two lines intersect, then the vertically opposite angles are equal. So angle O1 equals angle O2. If two lines are parallel to each other, then we know the following. Alternate angles are equal. Yes. In other words, angle 1 equals angle 2. Corresponding angles are equal. Angle 3 equals angle 4. Co-interior angles are supplementary, add up to 180 degrees. So angle 5 plus angle 6 equals 180 degrees. Right. Then, if triangle ABC is a triangle, then the following will be true. The sum of the interior angles add up to 180 degrees. So angle A plus angle B plus angle C equals 180 degrees. Then the exterior angle is equal to the sum of the opposite interior angles. In other words, angle C1 equals the sum of angle A and angle B. So as one that you really have to try to make use of a lot more. So angle A plus angle B equals angle C1. Now for the new work. Circle theorems. We're going to do around about 4 different theorems, and each of them has a theorem that has a opposite, the inverse of the original. But we will get to that. So very importantly, every time you're going to use these theorems regarding circles, the following needs to be mentioned. O is the center of the circle. That's why you see this before theorem 1a. This is one of the most important sentences you need to have in your question when you use the circle theorems. O is the center of the circle. If they don't mention this, then you cannot just use theorem 1a, b, 2a, b, 3a, b, or 4a and b. You can't, because it needs to be mentioned. So O is the center of the circle. Then the following can be used. Theorem 1a. The line segment connecting the center of a circle with the midpoint. The center of the circle with the midpoint of a chord will be perpendicular. In other words, it will be 90 degrees. Right? In other words, angle 1 M1 equals 90 degrees. Center of circle. So that symbol you see, this means circle. So you have to mention center of circle, semicolon, midpoint chord AB, and you have to name the chord. So we want both. We want that, center of circle, and midpoint of chord AB. So you may use the abbreviations like this, but we need both of them. Right, now theorem 1b. Now let's say we mention that the line segment from the center of a circle and which is perpendicular. So you can see they're already mentioning that it is perpendicular. In theorem 1a, you prove that angle M1 is 90 degrees. Now they tell you that angle M1 is 90 degrees. It's perpendicular to a chord. But now what you need to learn from this theorem 1b is that it will bisect the chord. So AM will be equal to MB. In theorem 1a, we mentioned that AM is equal to MB. In theorem 1b, you are rediscovering that AM is equal to MB due to the fact that the line from the center of the circle goes to the chord of the chord AB. Right. Very important, once again, the reasons. They are the most important, because that's what you get marks for. Right? Okay, so please just highlight that for me. Also this reason here. Now we just do an example. All right, so O is the center of the circle. You see it has to be there, so you check. Then OC is perpendicular to AB, right? Yes, there you see the 90-degree angle. OC is 6 centimeters and AB is 16. So calculate the length of AC and AO. Right, and this is how you will answer a question like this. So you will start with your statement. You will say AC equals 8 centimeters. How do we know that? We know that AB equals 16 centimeters. Now, to say that AC equals 8 centimeters, you have to give the reason. The line from the center of the circle to the center of the chord AB. That is your reason. So it needs to be there. Then you can go on. You can determine AO by using Pythagoras. Why are you allowed to use Pythagoras? Because they mention that that's a 90-degree angle. OC is perpendicular to AB, so therefore you can use the theorem of Pythagoras and get to the conclusion that AO equals 10 centimeters. Please fill it in on your sketch. Right, 10 centimeters, fill it in on your sketch. Right, then example 2. Once again, you need to find the phrase or sentence that says O is the center of the circle with radius 25 centimeters. There's the radius and there's the radius. AB equals BC. OB equals 15 centimeters. Calculate. So what's the question? Calculate the length of AC. So we want to determine that length. We have OB already as 15. We have OC as 25 centimeters. And actually, we have this radius over here also as 25. So we can determine, therefore, by using the theorem of Pythagoras, the length of AC. So you're going to start off with saying that angle B1 equals 90 degrees. Most important, the center of circle and the midpoint of chord AC. So mention that when you, and as you can see over here, initially they never drew the 90-degree symbol, so therefore you first have to prove it. So you cannot just assume that it's 90 degrees. You have to mention and give a reason why you're making the statement that angle B1 is 90 degrees. Why do you want to do that? Because you want to use the theorem of Pythagoras to determine AC eventually. Right? So now that you've proved you have a 90-degree angle, you can go and say BC squared equals 25 squared minus 15 squared. It gives you 400. So therefore BC equals 20. Remember to use the reason, Pythagoras, and then you can say AB equals BC. Why? You have to mention that they've given it to you here. So this you have to write down. You cannot just think the person who drew up the exam or test, they mentioned it already once. You have to mention it again. Why? Because the moderator of your exam paper will look at this part that I now indicate in purple. They're not going to worry about that much because they have a memo and they are looking for these 3 reasons and you have to write them down. So then you get to the conclusion AC equals 40 centimeters. So please remember, memo, this is not usually part of the memo. They are looking for your insight and how you can figure out a way by using the information provided. Then example 3. In the sketch, O is the center of the circle. You see, they have to mention it. We're looking for that. It has to be mentioned. OC is perpendicular to AB. Therefore, you have that 90-degree angle. Luckily, you see, you don't have to prove it. It's already been mentioned. OC equals 2 of CE. So 2 of the green lines here gives me 1 OC. So 2 of the green gives me 1 blue. So I need 2 of the green ones to give me 1 blue one. So that's what we're saying here. If CE is X and AB is 30 centimeters, determine the length of the radius of the circle. So in other words, determine OE. You will start off by saying OC equals 2x, given the information that OC equals 2CE. CE equals x, so therefore OC will be 2x. Then radius of the circle, if this is, for example, 2x, and that is x, then together they will be 3x. Right, so that's what we're saying. This is the radius. So AC equals 15 centimeters, line from the center of the perpendicular chord AB, and then you say OA equals 3 centimeters, the radius of the circle. You have to mention that. Now you can use the theorem of Pythagoras and get x, which will be square root 45. Right, but now remember the radius is 3x, not just x. So we need the value for 3x. Therefore, we will say the value of x, which is square root 45 times 3, which will give you 3 square root 45 times 3 gives you 9 square root 45. Right? So you guys know already that the simplified surd form is the most accurate form of an answer. So please always make sure if they don't specify that you have to round off your answer to 2 decimal places, give it in simplified surd form, and then in this case we gave the decimal answer that was rounded off to 2 decimal places. So then you can't go wrong. But always read your questions to see in which format they want it. Right, you guys, we're going to do exercise 1 now. So I'm going to do it step by step with you. You can press pause now, try it by yourself, or you can just continue listening now. Right, number 1, as we want and need our information, O is the center of the circle in each of the following questions. This needs to be mentioned. You know that already now. Number 1, in the sketch, OM is perpendicular to AB. OA equals 15 centimeters and AB equals 24 centimeters. So there we have the 24 centimeters, OA 15. Calculate the length of OM. So we want the length of OM, this one. So we're going to start off by saying that AM equals MB. The reason being line from center is perpendicular to chord AB. Then you write AM equals 12. How do we know that? Because 24 is the whole length of the chord, and we know that the line from the center that's perpendicular to the chord of AB will half it into 12 and 12. So therefore we can say that AM equals 12 centimeters. Now OM squared equals 15 squared minus 12 squared. So we're going to use the theorem of Pythagoras to determine OM's value. And then you will get OM as 9 centimeters. So please remember to just test to make sure by using the theorem of Pythagoras maybe to determine to see whether AO is 15. So you can test your answer with the theorem of Pythagoras. Then number 2, in the sketch MP equals PN equals 9, OP equals PC equal X. Calculate the length of OM. Right, so you have your 9 there and 9 there. Your CP is X and PO is X. Okay, so what you need to do is the length of OM. Right, so you're going to write that OM equals OC. Each of them equals 2x because both of them are radii of the circle. So you see over here, that's x and that one is x. So together we know that a radius will be 2x. Radius equals 2x. Right? So, and your reason being the radii of the circle. So we need this. Then you write P1, angle P1 equals 90 degrees. Reason, center of the circle, midpoint of the chord MN. So remember to also mention the name of the chord. Then you say, now you can use the theorem of Pythagoras to determine OM. And then you will get the value of x equals square root 27. Well, remember, we want our answers in the most accurate form, which will be simplified surd form. So please convert the square root 27 to simplified surd form 3 square root 3. And then remember, we ask you to calculate the length of OM. So OM equals 2x because it's a radius, just like OC. So therefore, you cannot just say x equals 3 square root 3. You have to say OM equals 2x. Therefore, 2 times 3 square root 3, which gives you 6 square root 3. And if you round it off to 2 decimals, then you will get 2,39 units. Then question number 3. In the sketch, AB equals 6, CD equals 8, and the radius of the circle is 5. AB is parallel to CD. So line AB is parallel to line CD, as you can see, and you guys need to determine the perpendicular distance between line AB and line CD. So you need to construct, because as you can see, there is not a line that's perpendicular. So you have to go and draw it. So you say construct, draw OP perpendicular to AB. Therefore, Q angle Q1 equals angle P1. So both of them will be 90 degrees each. Why? Because corresponding angles, lines AB are parallel to line CD. Right? Then AP equals PB, which equals 3. How do we know that? AB equals 6. So the whole AB here is 6. Therefore, AP to PB will be each 3. And CQ will be 4. And let's see what's the other one. QD will also be 4 because together the whole CD equals 8. So line from center is perpendicular to chords AB and CD. Now that you prove that you have 90-degree angles, now we can use the theorem of Pythagoras to determine OQ. So OQ squared equals OD squared minus QD squared. So we're determining this small OQ over here. We're using this right angle triangle over there, and you will get OQ as 3. You fill it in. OQ equals 3. Now you're going to determine OP. OP. That one over there. No, sorry, let me just indicate it properly. OP. So that is 3, and now we're going to determine the whole OP. That we're going to use Pythagoras' theorem. So OP squared equals OB squared minus PB squared, which is 5 squared minus 3 squared, which gives you 16. So OP squared equals 4. And it should actually be only OP, not OP squared. Okay, right. Please just make sure that you scratch out that mistake. Then we want to determine PQ. In other words, this is 3. OP is 4. So therefore, PQ will be 1, even though it doesn't seem it's logically possible, but it is. So PQ, in other words, equals OP minus OQ, which gives you 4 minus 3, gives you 1 unit. Right. Right, now we're going to look at the following angles that are subtended. So arch PQR or chord PR subtends angle S at the circumference. So angle S is called the angle at the circumference. So that's what we call that, angle S, angle at the circumference. Then arch PQ, arch PQR or chord PR subtends PQ, subtends, let me just read it again. Arch PQR or chord PR subtends the following angle: PQ POR, this one over here, that angle over there, POR at the center of the circle. Therefore, angle POR is the angle at the center. So that we call the angle at the circumference. Easy, it's on the circumference. This we call the angle at the center. Both of them has an arch or a chord that subtends, arch or a chord that subtends. Now theorem 2. The angle at the center that is subtended by an arch. So this angle over here, or chord of a circle, will be twice the size of an angle that is subtended by the same arch at the circumference. So in other words, the angle at the center will be 2 times the size as the angle on the circumference, and both of them needs to be subtended by an arch or a chord of the circle. So it needs to be the same arch and chord. Then we will say angle AOB equals 2 of angle C. Reason being, angle at the center equals 2 times the angle at the circumference. So 2 of the circumference angles give you 1 center angle. That's what it says there. Then the reflex angle AOB equals 2 of angle C, ACB. Right, so therefore the reason being, angle at the center equals 2 times the angle at the circumference. So 2 of these circumference angles will make 1 center angle at the center. Right, now we're going to look at theorem 3. The angle at the circumference, in other words, that one over there, that is subtended by the diameter is a right angle. So there you have the diameter, it's subtended by the diameter, and therefore it's a right angle. So we say that the angle in a semicircle is 90 degrees. So semicircle, which means half of a circle. So the angle in a semicircle that's on the circumference, that's subtended by the diameter, we call a 90-degree angle. So angle C equals 90 degrees, angle in a semicircle. Now the converse of theorem 3. If a chord subtends a right angle, like this one, we don't know that it's a diameter yet. So if a chord subtends a right angle at the circumference of a circle, so this chord subtends the right angle over here on the circumference, then the chord is a diameter of that circle. So if they don't mention that this is a diameter, but you see that it subtends a 90-degree angle on the circumference, then you know that it's not just a chord, it's actually the diameter or diameter of the circle. Therefore, angle R equals 90 degrees. Thus, PQ is a diameter or diameter. Example 4. Calculate the unknown values. O is in each case the center of the circle. So now we're going to just apply the theorem 2 as well as 3. So example 4a, we have to determine x. So x equals 36 degrees. Reason being, angle at the center equals 2 times the angle at the circumference. So 2 of the circumference angles gives me 1 angle at the center. Then b, x equals 30, angle at the center equals 2 times angle at the circumference. So this angle, and this is another version, so I want you to draw 4a, example 4a, as an example of an angle at the center equals 2 times angle at the circumference, and you're going to draw this one, number b, also, because that is the angle at the circumference, this is the angle at the center. So you need 2 of the angles of the circumference to make 1 angle at the center. So therefore, x equals 30 degrees and y equals 30 degrees because OB equals OC. OB equals OC because both of them are radii and equal angles opposite equal sides. So we're going to NB that. You need to remember that. Right, then I want you to also make a sketch of C under the heading angles at the center equals 2 times the angle at the circumference, theorem 3. We just make sure it's theorem 2. It's this one over here. Remember, they are all part of theorem 2. Theorem 2, theorem 2, theorem 2. So x equals 220 because it's a revolution, so it's this angle over here. So it's 360 minus 140 gives you 220. Then angle A equals 110, which is half of 220. Angle at the center equals 2 times the angle at the circumference. D, you're going to also make a sketch of x is the angle at the center, therefore it's twice as large as the angle at the circumference, so therefore it will be 48 degrees. X equals 48 degrees, angle at the center equals 2 times the angle at the circumference. E, angle AOC, the reflex one, equals 210. Angle at the center equals 2 times the angle at the circumference. So this is the angle at the center. This is the angle at the circumference. So 2 times 105 gives you 210. So now in order to determine that small little angle there, the x there, you're going to say 210, which is the whole blue one there, minus 180, because it's a straight line AOD, gives you 30 degrees. So x equals 30 degrees. Now, example 5. In each case, calculate the value of x. And I'm back. Sorry, I had to deal with a runny nose. I'm back. Right, in each case, calculate the value for x. O is the center of the circle in each case. You need to determine x. So angle C will be 90 degrees because it's a angle in a semicircle, and x then will be, so it's 180 minus 90 minus 20 will give you angle x, because we know that the interior angles of a triangle gives you 180 degrees. Therefore, x equals 70. Then B, determine x. So angle ACO equals 41 because you have a radius here and a radius there. OA equals OC, radii, equal angles, and you have to mention this. You have to mention radii as well as equal angles opposite equal sides. And then angle ACB equals 90 degrees, angle in a semicircle. Therefore, angle X will be 90 degrees minus that 41. Remember, there was a 41 over here. Gives you 49. So X equals 49. Then theorem 4. Angles in the same circle segment that lie in the circumference of a circle and which are subtended by the same chord or arch will be equal. In other words, the following. Angle ADB will be equal to angle ACB. For the simple reason both of them are subtended by the same arch in the same circle segment. and the same chord. So therefore angle D equals angle C. The reason angle subtended by arch or chord AB in the same circle segment. So remember, don't just write arch or chord, give the name. Then the converse of theorem 4, if a line segment subtends two equal angles, like this, on the same side of the line segment, the 4 points will lie on the circumference, all 4 of them. We say that the 4 points are concyclic, A, B, C, and D. So if angle D equals angle C, then A, B, C, D are concyclic. Right, now we're going to do deductions made from theorem 4, so you need to summarize this as well. Number 1, equal chords subtend equal angles at the circumference of the same circle. So it needs to be the same circle. So equal chords indicated by the lines there subtends angles at the circumference of the same circle. So equal angles. Therefore, if AB equals CD, then angle E will be equal to angle F. If angle E equals angle F, then AB will be equal to CD, vice versa. Then equal chords subtend equal angles at the center of the same circle. So if you have equal angles at the center of a circle, then the chords will be equal in length as well. So therefore this NB, if AB equals CD, then angle AOB will be equal to angle COD. So if angle AOB equals angle COD, then AB will be equal to CD. Then example 6, calculate the unknown angles X and Y. So X, for example, will be equal to 22. It will be the same as this one. It will be 22. So this one, as well as that one, will be equal to one another. Reason being, angle subtended by chord AB in the same circle segment. Same circle, same chord AB that subtends angle AEB and angle ADB. And then Y equals X equals 22 degrees also. Why? Because AB equals BC. And once again, equal chords subtend equal angles. So they can visually share the same chord, or it can be indicated that both chords are the same length, therefore both angles subtended by chord AB by the same chord, angle subtended by the same chord in the same circle segment are the same size. Right, guys, we're going to do exercise 2 now. We're going to do it together. Right, once again, very important information. O is in each case the center of the circle, so they have to mention that. Then you calculate X, Y, Z, and P, the values of X, Y, Z, and P. We start with X. So X equals 33 degrees. Okay, just write 33 degrees there. Why? Because equal angles opposite equal sides. OB equals OC, both of them are 80. Then Y will be 180 degrees minus 2 times 33 degrees, because the sums of the interior angles of triangle OBC equals 114. So this will be 114. Then angle Z will be half of 114 because angle at the center equals 2 times the angle at the circumference. So this will be 57 then. Theorem 2. Then angle P, angle BOC, in other words, this one here, the reflex angle, will be 360 minus this 114 because it's a revolution. Remember to mention it's a revolution. That gives you 246. 246 degrees. So therefore angle P will be half of that because of the reason angles at the center equals 2 times the angles at the circumference. So you used to the sketch, that's why I mentioned you have to draw all the sketches on the theorem 2 that they provided. Number 2, they mention OA is parallel to line CD, CB, and angle A1 equals 13 degrees. So determine values of X, Y, and Z. So angle X equals angle A1. Alternate angles, line OA is parallel to line CB, so remember to mention the parallel lines. Then Y equals 2 times 13 because angles at the center equals 2 times the angles at the circumference, which gives you 26 degrees. So this is the angle at the center, and that is the angle at the circumference. So Y is 2 times the size of X. And then Z equals Y due to alternate angles, lines OA being parallel to line CB. Now we go to 3. Calculate the values of X, Y, A, B, and C in any order. So So X equals 90. So this angle there will be 90 degrees because it's an angle in a semicircle. Y, that one over there, equals, if that's 90, this is 25, then we can determine this triangle ACD, and we can say 180 minus 25 minus 90 gives us 65 degrees. The interior angles of a triangle adds up to 180, so that's our reason. Sum of the interior angles of triangle. Please remember to name the triangle ACB because you can see there are various triangles. Then A equals B. Equal angles opposite equal sides, because this is a radius and that is a radius. So therefore OB equals OC radii, and you have to write equal angles opposite equal sides. Now you say small a angle equals small b. So it's 180 minus 64 divided by 2 because these two angles will be the same size due to OB being equal to OC in length. So that will give us 58. 58, 58. So that gives us 58. So now C plus B gives us 90 degrees. So it's an angle in a semicircle. So therefore, to get C, you have to say 90 because it's a 90-degree angle minus the 58 gives you 32 degrees. So C equals 32 degrees. Then note, T is not the center of the circle. Calculate the values of X and Y. Hint, draw chord DC. Okay, so you draw the chord DC. Then we know that this is not the center of the circle. So we say X equals 25 because of angles subtended by chord AB, one there, it subtends the angles D and C in the same circle segment. And then Y will be 30 degrees because they are angle D, B, and C, as well as angle C, A, and D are both 30 degrees each because they are subtended by the chord DC in the same circle segment. And then you name the chord, so chord DC. Right, now number 5. Determine X, Y, A, and B. Right, so angle O1, this one over here, equals 102 degrees. Okay, just fill in 102 there for me. Straight line, so you see line BOD. So 180 minus 78 gives you 102. Then X, this one over there, will be half of that because this is the angle at the center and that is the angle at the circumference. So the angle at the center equals 2 times the angle at the circumference. So if this one is 102, then that one needs to be 51. Right, now you say Y equals X. This one equals that one. Both being 51. Angle subtended by arch DC, this one over here, or it can be a chord in the same circle segment. Then angle BAD, BAD will be 90 degrees because it's an angle in a semicircle. So there's the 90-degree circle. There is the diameter line. So that angle there is 90 degrees. Small a equals 180 minus 90 minus 20 gives you 70. Sum of interior angles of a triangle ABD. Then angle OCB, this angle over there, equals Y equals 51. So both of them are 51. Equal angles of opposite equal sides. OB equals OC because both of them are radii. And then angle ACB, ACB, so this whole angle here, the 51 plus the B equals angle D, that angle there, which is 70, and angle subtended by chord AB, in the same circle segment. In other words, to get small angle B, you take the 70 minus the 51 and you get 19. 19. degrees. Okay, let's look at number 6. Note, T is not the center of the circle. Why is angle B1, that angle there, equal to X? Remember, that's not the center of the circle. Then you say equal chords subtend angles. AD is equal to BC. AD is equal to BC. So AD is equal to BC. Therefore, equal chords subtend equal angles. Therefore, angle B1 equals angle X. Right, then, hence calculate the value of X. So you need to determine the value of X. So therefore, you will say 2X, because it's X plus X. This is also X. X plus 42 equals 180 degrees, because we're now working in this triangle here. So the sum of angles of a triangle ATB adds up to 180. Therefore, 2x equals 138, x equals 69. So x equals 69. And then C, if angle A1 is 16, determine the value of B2. So angle B2 equals angle A1, angle subtended by chord DC in the same circle segment equals 16. Therefore, A1 equals B2. Right. Now we're going to just look at the summary of the theorems and reasons, so you can summarize this and put it up against your walls in your room so that you will remember your theorems. And then we're going to start with the homework, so you can give yourself 15 to 20 minutes in order to do it. So you can press pause now, work it out, and then you press play again after 15 or 20 minutes. Right, number 1, in the sketch, MD, let me show it on the memo. MD equals 2 centimeters. The radius of the circle is 10 centimeters. So in other words, this whole OD equals 10 centimeters. OM is perpendicular to BA. O is the center of the circle. I have to mention that, remember, for you to use the theorems of the circle geometry and calculate the length of BA. So we're going to start with OD equals OA. So in other words, these two are the same length. Both of them are 10 centimeters, radii of a circle. Therefore, OM will then be 8. So this little part here will be 8. Because the whole OD equals 10. Therefore, if the whole OD equals 10 and OA is also 10, then MO will be 8 and MD will be 2. 8 plus 2 gives you 10. Right, now we're going to determine OA. So OA squared equals, and we already know it is 10. We're going to determine now MA. This one over here. So MA squared equals 10 squared minus 8 squared gives you 36, and MA equals 6. So MA equals 6. That's 6. Then this one will also be 6. 6 centimeters. So BM equals MA. Line from center is perpendicular to chord BA. Remember that reason. And BA therefore equals 12. 6 plus 6 gives you 12. Then number 2. In the diagram below, O is the center of the circle. Chord AB is perpendicular to diameter PQ. So PR equals 4 and RQ equals 6. So it's in the ratio 4 to 6. So PR to RQ is 4 to 6. And AB equals 40 centimeters. So determine the expression for PQ in terms of X if PR equals 4 units. So 4 units, 4 plus 1x. 4x plus 1x give you 5x. Sorry, I'm now at the wrong part. We're determining PR plus RQ. So RQ equals 6 and PR only 4. So 4x plus 6x gives you 10x. Therefore, PQ equals 10x. But you have to write it in the ratio PR 4 to 6. RQ being 6. Then you say 4x to 6x. Therefore, PQ equals 10x. Then 2.2, determine the radius in terms of x. In other words, the radius will give you 5x. In other words, 4x plus 1x gives you 5x. Or you can say 10x divided by 2. Because the diameter is 10x, therefore, if you wanted the radius, you divide it by 2 and you get 5x. 2.3, determine an expression for OR in terms of x. OR, so OR is 5x minus 4x gives you 1x. So OR, this part over here, is only 1x. And we got that by saying the radius, which is 5, minus the 4 gives you 1. Then 2.4, hence calculate the length of the radius. So we're going to say AR equals RB, which is 20 centimeters. So in other words, this is 20 and RB is 20. Line from center perpendicular to chord AB. That's your reason. Then we're going to determine AO. This one here in blue. 5x in brackets squared equals x squared plus 20 squared. We're using the theorem of Pythagoras. Then you get x's value as square root 400 over 24. And round it off to 2 decimal 4,08. Remember, the whole radius is 5x, therefore we have to say 4,08 times 5, which gives you 20,4 centimeters. Right, now we're just quickly going to look at number 3. They mentioned that determine the values of angles A to M. O is in each case the center of the circle. No reasons are required for this question. So I'm just going to explain to you how I got to these answers, most of them, and then we will do question 4 and 5. All right. So small angle A, I will explain just now to you. Right, gives you H1 equals 30. Because equal angles opposite equal sides. So that's 30 and that's 30. Both of them are ADEs. Then B equals 50. Angles subtended by chord AC. Or arch AC there. So B equals 50 because of angles subtended by arch AC. Then C equals 60. This is a radius, that's a radius. This one will be 40. So 40 minus 180 minus 40 gives you 140. So that gives you 70 and 70. Then E equals 150. So the exterior angle here equals 210. So 360 minus 210 gives you 150 for E. So first you determine this one, which is 210, because the angle at the center equals 2 times the angle at the circumference, and then it's a rotation, so 360 minus 210 gives you 150. Then F, here, it gives you alternate angle, so that one F will be 42. G will also be 42 due to the arch AD subtending the angles. Then H will be 32. Because you say 64 plus 42 equals 106, and 180 minus 106 minus the 42 gives you 32. Then I equals 123. J equals 90 because it's an angle in a semicircle. K equals 23. Angle at the center equals 2 times the angle at the circumference. L equals 44, so this angle equals 44, and M equals 67. Right, so I'm just referring to the again, K equals 23, L equals 44, and M equals 67. Right, then we go to question 4. Just remember, you don't have to give any reasons for this activity. in question 4 you do have to give. M is the center of the circle, angle BMD equals 130, and angle DEC equals 25. So now they want to show that angle EDC, in other words, this angle over here, equals 90. So you're going to start off by saying that angle DMB is a reflex angle, so it's 230, because you say 360 minus 130 will give you the 230 there, revolution, that's your reason. Then angle DEB, this angle over here, equals a half times 230, because angles at the center equals 2 times the angle at the circumference. So the 230 here is the angle at the center, and this is the angle at the circumference. So therefore that one is 115. And then angle DEB equals angle C plus angle D, because it's the exterior angle of triangle DEC. Therefore 150 equals 25. So in other words, what you're doing is this angle is the sum of this one plus that one. So therefore, this one being 115, that one being 25. So 115 minus 25 gives you 90. So there you have the proof that angle EDC equals 90 degrees. And then number 5. In the sketch, M is the center of the circle, AB equals CB. If angle M1 equals 8x, express the following angles in terms of x and give reasons for the statements. So 5.1 A2, in other words, this one over here, will be equal to B1, equal angles opposite equal sides. The radius being this one and that one, 2 radii. Look at the reason. Then A2 will therefore be 180 minus x divided by 2, because this angle equals that one. Sum of the interior angles of triangle A and B. That gives you 90 degrees minus 4x. So angle A2 is 90 degrees minus 4x, and angle B1 is also 90 degrees minus 4x. Now they ask you angle 5.2, angle ACB. Angle M, this one is a reflex angle. So it's 360 minus this 8x. It's a revolution. So therefore, this is the angle in at the center. So it will be twice the size of the angle at the circumference. So it's 360 minus 8x divided by 2 gives you 180 minus 4x. So angle ACB equals 180 minus 4x. And the reason being angles at the center equals 2 times the angles at the circumference. Then angle 5.3, angle 3, A3, in other words, this one, A3, will be equal to angle B2 because of equal angles opposite equal sides, AC and CB being equal to one another. Therefore, A3 equals 180 minus the 180 minus 4x, which was the answer that you got here. $180 minus 4x. We just do it properly. that gives you 4x divided by 2 gives you 2x. So in other words, this is equal to 2x. A3 is 2x, B2 is 2x. And then 5.4 angle D over here is equal to angle B2, this one, which is equal to 2x, angle subtended by chord AC. So in other words, this angle is the same length as that angle there due to this chord AC being in the same segment and subtending an angle D and angle B2 being subtended by the same chord AC in the same circle segment. Right guys, that's now the end of the lesson. Please go through the sums again and make sure that you do make your summaries. Thank you.